Hello, I'm Andrew Sears from the Human-Computer Interaction Lab in the Computer Science Department at the University of Maryland in College Park. Today I'm going to introduce you to my dissertation research, which focuses on applying simple task descriptions to interface design and evaluation. Interface designers often consider the user's tasks when selecting the widgets that are necessary for an interface. However, they do not always consider the tasks when organizing these widgets. Many existing systems appear well organized and follow design guidelines, but are inefficient when the user's tasks are considered. We developed a metric called Layout Appropriateness to assist designers in organizing interfaces. This metric incorporates a description of how frequently users perform each sequence of actions into the process of creating and evaluating user interfaces. This is a mock-up of a screen designed for NASA to control a robotic arm. One of the most frequent tasks involves setting the mode for the arm, releasing the brakes, and confirming the brakes should be released. Notice the large movements that are currently necessary to accomplish this task. Considering the user's tasks and using the layout appropriateness metric allowed an improved organization to be designed. Notice the sequentially selected objects are now closer together. These two designs and a third alternative design were evaluated in a controlled experiment. The results indicated that after limited practice, interfaces with higher layout appropriateness values resulted in faster performance and better user preference ratings. Additional examples of existing interfaces which may be improved by considering the user's tasks are easy to find. For example, this Macintosh dialog box is fine for tasks which involve selecting a folder and then typing a file name. However, when the task involves selecting a drive, this design becomes less appealing. With this redesigned layout, users must move a little farther to select a folder. But this design is much more efficient for tasks which involve selecting a new drive. Another example can be found in Microsoft Windows. This dialog box from the editor right appears well organized, and opening a file is easy. However, when the file is in a different directory, this layout appears less logical. Notice with this new layout, selecting a file is still simple. In addition, opening a file in a new directory is also simple. These ideas have also been applied to the task of creating a new, more efficient menu organization. Considering not only the traditional or expected ordering for menu items, but also how frequently each item is selected, allowed us to create a new menu organization we call split menus. A traditional font menu would have all of the items listed alphabetically. Understanding how frequently items are selected allows the menu to be reorganized, making the selection of high-frequency items easier. This new menu organization has been evaluated in 2 field studies and a controlled experiment. The results indicate that split menus allow users to make faster selections, and that users prefer split menus over the traditional alphabetical menus. These ideas have demonstrated the potential of using simple task descriptions for designing and evaluating user interfaces. Now we must develop additional techniques that can take advantage of this rich source of information.